everyone, and welcome back to Chapter 1, Section 1.3, concerning linear equations in two variables. Yay, fun. Okay, so what are the objectives of this section? So the goals of this section are to 1, use slope to graph linear equations in two variables. 2, find the slope of a line given 2 points on the line. 3, write linear equations in two variables. And then use slope to identify parallel and perpendicular lines. And then finally, use slope and linear equations in two variables to model and solve real-life problems. So we can do this. Actually, you may recall we did a bit of this in the last class, so pretty exciting. All right, so let's start off with slope. So the simplest way of relating two variables in linear form is y equal mx plus b. This equation is called linear because the graph is a line. So in math, when you say a line, you're talking about a straight line. Okay? So when you let x equal 0, you get y is equal to m times 0 plus b, which means it's just b. So what is that saying? That's saying that what? Your y-intercept is b, yeah? So the line crosses the y-axis as y equals b here. So you get the point 0b, or here 0b, it's the y-intercept. So remember, if you have a positive slope, the line rises. And if you have a negative slope, the line decreases or falls as you're looking at the line from left to right. Okay, so just to restate that, the y-intercept is 0, b. The steepness or the slope of the line is represented by the letter m. Okay, so what exactly is the slope? The slope of a non-vertical line is the number of units that the line rises or falls vertically for each unit of horizontal change from left to right. So if you were to go by 1 unit, it rises m units, and if you go this way 1 unit, it will fall m units. In other words, remember we said rise over run. So linear equation in the slope intercept form has this form y equal mx plus b. There are other forms, but this is the one that we're focusing on right now. It's because you can look at it and you clearly see the slope is m and the y-intercept is 0b. Okay, so once you determine the slope and the y-intercept of a line, it's relatively simple to sketch its graph. Okay, so like note for this example here, we're looking at, note that none of the lines are vertical. Well, before we get into that, let's say here, what is a vertical line? A vertical line is a line that goes straight up and down, right? That has the form x equals a. So we cannot, this is an exception of the rule, right? So the vertical line is exception because the slope of this line here is undefined because you have 0 run. So if you think of it as rise over run, anything divided by 0 is undefined. So we cannot write the equation of a vertical line in the form y equal mx plus b because the slope is undefined. So the vertical line has equation x equals some number, whatever it is. So like in this case, x equals 3. Okay. So let's do some graphing. If you can remember, you can hit pause on the video and try the next 3 examples on a piece of paper, and then we can compare notes. So I will give you guys a couple seconds to hit pause and try these on your own. Okay, welcome back. Let's check our answers, shall we? So for example 1, we have here y is equal to 2x plus 1. We have the y-intercept is at 1, so here at 1, 0, 1. And the slope is 2, so you go rise up 2 over 1. So that's rise over run, okay? All right, so that is, if you drew a line going this way, then that's correct. So for the second one, y is equal to 2, period, no x, so that's 0. if you write it in this form, you could see that the y-intercept is 0, 2, so right here, and that the slope is 0. Okay, so 0 slope means that the line is horizontal, it does not rise or fall. Okay. All right, so now this one is x plus y equals 2. We need to put it into a slope-intercept form. So how do we do that? We subtract both sides by x, and you get the following. You get y is equal to negative x plus 2. Okay, so we write that in slope-intercept form. That tells us that our y-intercept is 2, and our slope is negative 1. Okay, so that means it goes down 1 over 1. Down 1 over 1. Okay. So yes, so if this was your graph, congratulations, you have done it correctly. Okay. So next part is to find the slope of a line. So if we have an equation of a line, we can easily find its slope by writing the equation into y equal mx plus b form, slope-intercept form. If we're not given an equation, we can still find the slope of a line, okay? So let's say, for instance, in general, we wanted to find the slope of the line passing through these points, x1, y1, and x2, y2, right? So the rise is the difference of the y's over and the run, which is the difference of the x's. Okay, so the change in y. So here we go. So if we go from left to right, you see that there's a change in the vertical direction and a change in the horizontal direction. Oh. Excuse me. So y2 minus y1 is the change in y, also known as the rise. And x2 minus x1 is the change in x, also known as the run. So this ratio is our slope, rise over run, right? Change in y over change in x. Oh, there it is. Beautiful. So you have slope is change of y over change of x, also known as rise over run, even more specifically known as y2 minus y1 over x2 minus x1. So that is our equation to find the slope of a line. So if you want to find the slope of a line going through x1, y1, and x2, y2, you take the difference of the y's over the difference in the x's, okay? Now, the only thing is that x cannot be the same, because then that will mean that the line is vertical and therefore undefined. Okay, so make sure that we, when we're doing the slope formula, the order of subtraction is important. We need to, if we have 2 points on a line, it's helpful to label one of them as x1, y1, and the other x2, y2. So then once you've done that, you need to make sure that you have the same, the numerator and the denominator have the same order of subtraction. Okay, so it's not, you're not going back and forth. So let's say, for instance, if you did y2 minus y1 over x2 minus x1, that's fine. Y1 minus y2 over x1 minus x2 is also fine. You'll get the same answer either way. So you just need to stay consistent. Take the difference of the 2 y's over the difference of the 2 x's, making sure that you're calling from the same point, okay? Let's see here. So let's say, for instance, you have points 3, 4, and 5, 7. So in this case, the change of the y's were here. So 7 minus 4 is on top. The change of the x's is 5 minus 3, which is 2. So we have 3 over 2. That's our slope. Now, if we change the order, right, if we let, this one be the first one and then this one, the change of y's would now be 4 minus 7, so up here, and the change in x's would be 3 minus 5, so down here. So you would get negative 3 over negative 2, which is equal to 3 halves. So you see, get the same thing. Okay, so now here's your, now you try. So I'm going to give you guys a chance to try the next 4 points. So go ahead and push pause on the video. All right, so push pause and try them at least for yourself, and then unpause and let's see if we got the same answer, okay? Okay, so let's go through it. So let's say here we have let x1 and y1 equal to negative 2, 0, and x2, y2 equal 3, 1. So x1 is negative 2, y1 is 0, x2 is 3, and y2 is 1. So change in y, so taking the difference of the y's over change in x. So you have 1 minus 0 on the top, and on the bottom you have 3 minus a negative 2. So 3 minus a negative, when you subtract a negative, that becomes positive, and so in the denominator you get 5. Your slope is 1/5. All right, so congratulations if you got the correct answer. Let's do the second one. What is the slope of a line passing through negative 1, 2 and 2, 2? So change of y over change of x. So 2 minus 2 over 2 minus a negative 1. 0 over 3, 0 divided by anything is just 0. And boom, you have a slope of 0. And of course, then that means that the line is horizontal going through those 2 points. Bonus points, what's the equation of this line? The equation of this line, if you can say it out loud, amazing, it's y equals 2, yeah? Because 2 is constant. Okay, so finally, if we want to find the slope of the line passing through, oh no, almost finally, we need one more after this. 0, 4, and 1, negative 1 is change of y over change of x. Negative 1 minus 4 over 1 minus 0 is just negative 5. So it goes down 5 and over 1. And then lastly, if we have 3, 4, and 3, 1, if we were to plug this into the slope formula, we would get 1 minus 4, 3 minus 3. But wait a minute, we cannot divide by 0. It's undefined. So our slope is also undefined. Furthermore, that tells us that this is a vertical line going through these 2 points with equation x equals 3. All right. So now we're going to continue into the next section, which is writing linear equations into variables. So suppose you have x1, y1. Let that be a point on a line with slope m, and let x, comma y be any other point on the line. Then, using the slope formula, you could plug that in, right? And if I solve this for if I multiply both sides by x minus x1, I have obtained what we call the point-slope form of an equation of a line. Why is it called point-slope form? Well, because in order to solve this equation, you just need one point and the slope. Boom. Mathematicians, we're not that creative. We just usually have the definition in the title or the name of whatever it is we're talking about. So this is point-slope form because you need a point x1, y1, and the slope m. Okay, so this is super useful for finding the equation of a line. So let's say here you have a problem that says find the slope-intercept form, so that's different, of the equation of a line that has slope 3 and passes through the point 1, negative 2. So I have a point and I have a slope, so I'm going to use the point-slope formula, okay, and plug it in. Plug in m is equal to 3 and x1, y1 is equal to 1, negative 2. So x1 is 1 and y1 is negative 2. So boom, here's my equation. Boom, I plug it in. Okay, cool, so far so good. I put in negative 2 for y1 and 1 for x1. Everything else remained the same. And now I just simplify, right? Those two negatives here became a positive, and I solve for y by subtracting both sides by 2. And negative 3 minus 2 is negative 5 today. So you get finally y is equal to 3x minus 5. So here it is. Y-intercept at negative 5 goes up 3 over 1, up 3 over 1. Okay? All right. So, so if we have, let's say we only have 2 points. Let's say we only have 2 points, x1 and y1. Okay? Then what we could do to find the equation of the line, first we find the slope by subtracting a change in y over change of x, good. And then we use that m and pick a point to put it into the slope form, point-slope form. Okay? So this looks pretty crazy, but you don't even need to, instead of this right here, you just put m once you solve for m. Okay? All right. Next topic, parallel and perpendicular lines. Because we're talking about slope, it makes sense that we're going to go ahead and continue talking about parallel and perpendicular lines. Okay, slope can tell us whether two non-vertical lines are parallel, perpendicular, or neither. So here they are. If two lines are parallel, if and only if their slopes are equal. So if you have two different lines and their M1 is equal to M2, right? Their M's are the same. You can say that these two lines are parallel. And for perpendicular, two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other, meaning that, let's say you have one of them is -2, then the other one would be a positive 1/2. Okay, they're negative reciprocals. So let's do an example. So find the slope-intercept form of the equations of a line that pass through the point 2, -1, and are either A, parallel to, and B, perpendicular to the line 2x minus 3y is equal to 5. So it's kind of worded interestingly, but what you have to do is basically take this equation here, 2x minus 3y equal to 5, solve for y, get that slope, okay, use that slope and this point to find a line parallel, and then use the reciprocal, negative reciprocal of the slope, and the same point to find the perpendicular line. So let's do that. Okay, so we wrote this in slope-intercept form, check. So what's my slope? 2/3. Okay, so 2/3 is right here, okay? And we want a parallel line going through that point, and we want a perpendicular line going through that point. So any line parallel to the original line has to have that same slope of 2/3. So using this slope and this point, we plug it into point slope formula, y minus y1, that's -1, is equal to m, that's 2/3, parenthesis, x minus x1, which is 2, so n parentheses, that's my point slope form, and then we just solve. So these two negatives become a positive, and if we multiply both sides by 3, we get rid of this 3 on the right-hand side, you get 2 parentheses x minus 2, and 3 parentheses y plus 1. Then do distributive property, so you get 3y plus 3 equals 2x minus 4. Subtract by 3, and then you get, and divide by 3. So then you would get 2/3 x minus 7/3. Okay, so then to find the perpendicular one, any line perpendicular to this line that has 2/3, the original, has to have a negative reciprocal slope. So the perpendicular line will have a slope of -3/2 because that is the negative reciprocal of 2/3. So now you have your slope and you have your point. What are we going to use again? You got it. We're going to use point slope formula again. So there it is. Here's x, here's y, x1, y1. Plug that in. Plug in your slope. Okay. Now we need to we can solve the same way. So these two become a plus. Multiply through by a 2. That cancels out this denominator 2, so giving you -3. Then you have 2 on this side right here. Now you use distributive property. So we get 2y plus 2 is equal to -3x plus 6. Y plus 6, negative and a negative make a positive. Okay, and then we're solving for y. So subtract both sides by 2. Right? And then you would divide everything by 2. So you would get -3/2 x plus 2. Okay, so in this last example, the slope-intercept form was used to obtain the information, whereas the point-slope form was used to write the equation. All right, let's do a few applications. So, in real life problems, these are very common. So the slope of a line can also be interpreted as a ratio or a rate. So if the x-axis and the y-axis have the same unit of measure, the slope has no units and is a ratio. When I'm talking about units of measure, I'm talking about like inches, centimeters, feet, that kind of stuff. So if the x and the y-axis have different units, the slope is a rate or rate of change. Okay. So let's see here, maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. Is that ramp steeper than recommended? Okay, so how would we do this? We're obviously comparing rise over run, yeah? So the horizontal length is 24 feet, or we need to convert it to the same unit. So 12 times 24 is 288 inches. And then, so the slope would be vertical over horizontal, so 22 over 288. So once you simplify that, you would do 0.076. So 1 over 12 is 0.083. So the slope of the ramp is actually not steeper than recommended. Okay, predicting sales. The sales for Best Buy were approximately $49.7 billion in 2009 and $50.3 billion in 2010. Using only this information, write a linear equation that gives the sales in terms of the year. Then let's predict the sales in 2013. So we let t equals 9 represent 2009. Then you have you can represent the dates by the points 9, comma 49.7 and 10, comma 50.3. The slope of the line through these points is m is equal to 50.3 minus 49.7 over 10 minus 9, which is 0.6. You can find the equation that relates y to t to be, so y minus y1 is equal to slope m times the quantity t minus 9. So then if you solve it, you just get y is equal to 0.6t plus 44.3. So what does that mean? So then we have, that means that the sales for 2013, we're going to just plug in a 13, 0.6 times 13 plus 44.3. So that gives us 7.8 plus 44.3, which is equal to 52.1 billion. So this prediction is called, this method that we just used is called linear extrapolation. Sounds kind of funny, but what it means is basically like estimating, right? So an extrapolated point doesn't lie between the given. It's usually, when the estimated point lies between two given points, the procedure is called linear interpolation. So I guess extrapolation, you could think of it as it's outside, and inside interpolation. Sometimes, because the slope of a vertical line is not defined, its equation cannot be written in slope-intercept form. However, every line has an equation that can be written in this general form, ax plus by plus c equals 0, where a and b are not both 0. Okay, so here we go. This is a summary of everything we've covered. General form, ax plus by plus c is equal to 0. Vertical line is in the form x equals a. Horizontal line is form y equals b. Slope-intercept form is y equal mx plus b. Point slope form is y minus y1 equals m times the quantity x minus x1. And then this 2-point form, basically, it's instead of the this change right here, you can write an m. It's the same thing as point slope. Notice that's the same thing.